Inside the shadow of Geneva, beneath the Earth's floor, lies a shock of human imagination and a potential harbinger of obliteration, the immense Hadron Collider. It is a manual of legitimate examination, permitting specialists to review the subatomic world, ultimately inciting the discovery of the strange God particle. A long-term goal, now achieved, but physicist Brian Cox has recently made a chilling declaration that sent astonishment waves throughout the local scientific community. Something stressing has been analyzed at CERN, something that might have results in ways beyond our comprehension. Has our mission for knowledge set us on an impact course with catastrophe? Join us as we dig into the pit of this intellectual riddle. But before we jump into the declaration, let's explore what sizable particle gas peddles the significant Hadron Collider, LHC. The LHC, worked by CERN, is a 17-mile ring of superconducting magnets and the world's greatest and most powerful atom smasher. It represents the apex of human scientific achievement. In fact, it is strong enough to replicate the very conditions of the universe's creation to the world. But should this system, designed to open the inner measurements of the universe, maintain the way to something undeniably more troubling? Founded in 1954, CERN is one of the world's most prestigious research organizations, with 23 member states and a vast network of scientists. It is a hub for collaboration and innovation. The LHC is CERN's flagship project, though it is just one part of a massive network of particle accelerators and detectors, but not for engines or horses. This race is for subatomic particles, and it's a race toward existence itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy of the universe at the moment of the Big Bang. The effects create temperatures 1 million times hotter than the core of the Sun. A massive array of magnets guide the protons on their journey, while intricate cooling systems maintain the magnets at temperatures colder than space itself. These include 1,232 dipole magnets, which bend the beams, and 392 quadrupole magnets, which focus the beams. Just before impact, another type of magnet is used to squeeze the particles closer together, increasing the chances of collisions. The task of causing them to collide is similar to trying to make two needles, 6 miles apart, meet with the exactness required. The advancement is unparalleled. The LHC's design is a marvel of planning. It integrates two nearby, identical support point lines that lie hidden 574 feet below ground, shielded from the Earth's radiation. On this underground site, the entire system is cooled to a temperature of -456 degrees Fahrenheit, colder than the vacuum of space itself. This cold environment is essential for the superconducting magnets to function optimally. The support points in the LHC are made to collide at 4 locations across the accelerator ring, each corresponding to one of 4 particle detectors: ATLAS, CMS, ALICE, and LHCb. Each fulfills a unique purpose, exploring various aspects of particle physics. Together, they pass equally epic cameras, capturing images of these impacts. Scientists then sift through the debris, searching for signs of the elusive Higgs boson, otherwise known as the God particle, and other peculiarities that point to the fundamental structure of the universe. It's like looking at a limitless jigsaw puzzle, one in which the pieces are indistinct, and the picture is difficult to comprehend. By focusing on the microcosm, we gain pieces of understanding into the universe. But with each reaction comes another question, and with each discovery, another check. The LHC is not just an intellectual tool, it is a symbol of human curiosity and progress. It embodies our chosen journey for knowledge and our desire to uncover the fundamental forces that shape our universe. But as we push the boundaries of what we know, we must also remember the ethical and existential questions that arise. What are the risks of examining the unseen world? Should our quest for knowledge inadvertently unlock powers beyond our control? Within the sacred hallways of CERN, where the limits of human understanding are constantly pushed, a revelation has emerged that sends a chill down the spine of even the most seasoned scientists. Brian Cox, a leading physicist at CERN and an expert voice in the field of particle physics, has recently made a statement that has left the community both fascinated and alarmed. Cox's words reverberate with unsettling significance. The goal of CERN's Colossal Hadron Collider is to replicate a mini Big Bang. Yes, you heard that right, a smaller-scale version of the very event that birthed our universe. The physicist also highlighted the potential repercussions of this objective, pointing out the LHC's enormous capacity for making new discoveries. This includes its ability to unlock the mysteries of the Higgs boson and to study dark matter, the unseen substance that makes up much of the universe. Considering the power of the LHC to summon the very essence of the universe is an enticing opportunity, but one fraught with risk. The idea of the mini Big Bang is not just a theoretical concept, it is a tangible reality within the LHC. The temperatures, pressures, and raw energy all replicate the conditions of the universe's earliest moments. It is like witnessing the dawn of existence itself. But with such power comes grave responsibility, and the question arises, what if something goes wrong? Take, for example, the incident in 1978, when Russian physicist Anatoly Borsky encountered a catastrophe that could have altered the course of his life. Borsky was working at the U.S. synchrotron at the Institute for High-Energy Physics in Russia when a malfunction caused a proton beam to strike him. The beam entered through the back of his head and exited through his nose. Borsky's experience was both horrific and fascinating. He witnessed a flash brighter than 1,000 suns, yet miraculously, he suffered no immediate harm. The beam left a trail of destruction, damaging tissue and bone, but Borsky remained conscious and even walked himself to the treatment center. The result was a mix of shocking injury and remarkable survival. He did lose hearing in one ear and experienced partial facial paralysis, but his mental faculties remained intact, and he continued his scientific work. This incident, while not a personal tragedy, serves as a cautionary tale, underscoring the immense energy and potential dangers associated with particle accelerators. The risks of an accelerator like the LHC should not be underestimated. The potential for unintended consequences, the very fabric of reality being altered, these are not the stuff of science fiction. They are genuine concerns voiced by some in the scientific community. One of the most terrifying and exciting concerns related to the LHC's experiments is the possibility of creating a tiny black hole. Black holes are regions of spacetime where gravity is so intense that not even light can escape. These cosmic vacuum cleaners devour stars and other matter, and the idea that the LHC might create such a phenomenon, even on a microscopic scale, has intrigued and alarmed both scientists and the public. If this black hole were to form, would it grow uncontrollably and consume the Earth from the inside out? CERN scientists have assured the public that any black hole produced would be unstable and disappear almost instantaneously. Yet the remote risk has ignited debates, fears, and awe at the power we are harnessing. Understanding how the LHC could generate a black hole involves the intricate mechanics of particle accelerators. When protons are accelerated nearly to the speed of light, the resulting energy is so immense that it could warp the very fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy weight is dropped onto it, the surface bends, and if the weight is large enough, it could create a pit so deep that anything nearby would fall into it. This metaphor offers a simplified view of what might happen at the LHC in the realm of quantum physics, where the universe's laws are both strange and astonishing. There is a theory that much larger forces might be hidden within our reality, and if these forces exist, the LHC might exploit them, creating a gravitational tunnel that forms a tiny black hole. This complex dance of particles has even captured the attention of some of the world's most renowned scientists. Stephen Pedling, in his book Stellus, forewarned of a situation wherein the Higgs boson ought to end up being fickle at incredibly exorbitant energy levels. This unsteadiness might need to cause an overwhelming vacuum decay, a vainglorious event that wouldn't simply destroy the Earth, but the entirety of the universe itself. The esteemed English cosmologist and astrophysicist Sir Martin Rees imparted his own leisure activities around the appraisals driven at CERN. In his digital book On What's to Come, Potential Opportunities for Mankind, he examined the plausible dangers related to atom smasher appraisals, which include those at CERN. His words were not simply precautionary, they were touched with a sensation of existential stress. He referenced the most dire outcome imaginable, conceivable, where a tragic examination could make a situation known as vacuum trickiness. This precariousness should, in theory, trigger a degree of progress that would reverberate through the real surface of space-time. The eventual outcomes would be a huge catastrophe that would destroy the entire universe. Riese's inclinations were not limited to theoretical experiences. He assigned a possibility to those overwhelming impacts, however a low one. At any rate, even a minute possibility, he thought, should give us probability to pause and reflect, for the stakes are impossibly high, and the margin for error is razor-thin. The scientists at CERN have determined the potential risks related to their tests carefully. They have executed various safety protocols and precautions to mitigate any conceivable risks. Yet, the idea of scientific investigation intrinsically involves some level of uncertainty, particularly when diving into strange regions. The quest for knowledge has forever been interwoven with a level of risk-taking over the entire course of time. Scientific breakthroughs have often come with unanticipated results. However, it is precisely this willingness to push limits that has moved humankind forward. The LHC represents the zenith of hundreds of years of scientific progress and exemplifies humankind's unquenchable curiosity about the universe. By the way, the potential dangers posed by experiments at the LHC can't be disregarded. While the probability of disastrous events might be low, the results could be significant. Hence, it is fundamental for researchers, policymakers, and the general public to engage in open dialogue about the ethical and safety implications of such research. In the end, the Hadron Collider at CERN is a wonder of human resourcefulness and scientific accomplishment. It offers rare insights into the key nature of the universe. However, with great power comes great responsibility, and it is vital to approach this momentous examination with watchfulness and foresight. As we continue to unlock the mysteries of the universe, we must stay cautious and aware of the potential dangers involved, ensuring that our pursuit of knowledge does not come at the expense of our security and well-being. The Hadron Collider at CERN stands as a testament to humankind's constant quest for knowledge and understanding of the universe. Its immense size and complexity represent centuries of scientific progress and collaboration among nations. However, beneath its inspiring veneer lies a domain of significant scientific inquiry, laden with potential risks and moral considerations. The collider's primary objective of unraveling the mysteries of particle physics has led to historic discoveries, including the elusive Higgs boson. However, the extraordinary energies created within its tunnels also raise concerns about the potentially negative consequences of such endeavors. While extensive safety measures are in place to mitigate risks, the chance of catastrophic events, like the formation of many black holes or other unexpected anomalies, cannot be completely ruled out. Therefore, as scientists push the limits of our understanding, it is crucial that they do so with a deep awareness of the potential consequences and transparency. Engaging in public discourse with policymakers and the public is essential to address concerns and ensure the ethical conduct of research. In this balance between scientific exploration and safety, the Hadron Collider represents both the pinnacle of human achievement and the sobering reminder of the need for caution. As we continue on our quest for knowledge, the global academic community's collaboration and commitment to advancing our understanding of the universe through projects like the Hadron Collider represent humankind's collective pursuit of truth. The collider's complex design and cutting-edge technology allow scientists to recreate conditions like those that existed fractions of a second after the Big Bang, providing valuable insights into the fundamental building blocks of existence. However, as with any momentous endeavor, there are inherent risks and uncertainties that come with such ambitious efforts. Despite thorough safety protocols and careful planning, the potential for unforeseen outcomes remains a constant consideration. Beyond the realm of scientific inquiry, the ethical implications of experimenting with such powerful forces are significant. Questions surrounding the potential impacts on the environment, as well as the broader implications for society and future generations, warrant careful attention. As researchers grapple with these complex issues, public engagement and transparency become essential pillars of responsible research conduct. Moreover, the pursuit of knowledge must be guided by a commitment to safeguarding human well-being and the integrity of the natural world. This requires ongoing dialogue and collaboration among scientists, policymakers, ethicists, and the public to ensure that scientific advancements align with ethical principles and societal values. In exploring the frontier of particle physics, the Hadron Collider serves as both a symbol of human creativity and a sobering reminder of the profound responsibilities that accompany scientific progress. As we continue to push the boundaries of our understanding, it is critical that we do so with humility, reverence for the unknown, and an unwavering commitment to the well-being of our planet and its inhabitants.